Hi everyone. So today we'll be discussing electrical power supply system. So from last time, na-introduce ko sa inyo what is power system. Basically, we talked about how ano yung primary components, I think, ng isang power system. Ano ba yung makikita natin within that system? And then we talked about the power system in the Philippines. Ano yung current state ng ating generation sector, ng ating load demand, etc. And then ano yung existing laws that reformed yung ating electric power system into what is it now, what is now. So for today we'll be looking into, we'll actually be browsing, will not dive deep into electric power supply systems, but we'll be browsing we'll be browsing the technologies na meron dito sa ating electric power supply system. Of course, when we talk about electric power supply system, ang una nating naisip is generators. Well, it's primarily because your power supply is mainly, a large part of that is coming from your generators. But uh, aside from that, we'll be talking about other technologies that serves as your power supply. Okay. Yeah. So you know about generator from your EE41 before. Uh, you know how voltage is induced, how current is induced. So basically, how we generate power from that generator. You have the rotor, you have the stator, you have the. It's basically the principle of electromagnet. If you can still remember, your EE51 is electromechanical conversion in DC. So it's basically DC, but I think on your EE50 you were uh anong tawag dito, acquainted with how is power generated in AC. So it's basically the same. Meron lang components na dinadagdag on your AC generator for it to be converted into the DC, but it's basically the same. So your generator is its main purpose is this one. Alin nga ba dito? This one. Yeah. Its main purpose is this one. Uy. Ay, okay. Sorry. Its main purpose is to produce electrical energy to meet the demand and system loss. So yun. So that's what we want to get from a generator. Okay, so you want to produce electrical energy. And it's basically what your generator is doing. Okay? But if you can still remember from your EE50, your power is, it's basically a vector sum of your real power and the parent power. So you have a reactive and reactive power. So you basically have a reactive component. So because of that reactive component, hindi lang your generator, because of that reactive component, ay nagkakaroon ng added function besides meeting the meeting the demand, because the demand is usually in kilowatts. It's in kilowatts. Yun yung load. That's the consumption of the of the people, of the consumer, of the end user. The end user is consuming kilowatts. It's not really consuming kVARs, but kVAR is more of a manifestation of your power due to reactive elements. You have the inductors, you have the capacitors within that system. So it's manifested as reactive power and not real power. But the power that is being used by your consumer, your end user, is it's basically real power. So yeah. Okay. So because your generator can generate that kVAR and not just kilowatts. So it's used to balance energy and stability. Okay? So there are a lot of problems in stability na gumagamit tayo ng generators para mabalik yung stable state ng ating system. Okay, you have the overcurrent, you have the power system protections that detects anomalies, and then under voltages, over voltages, that you do something with the generator for to be solved. You have the dynamic behavior, yan. You have the voltage support. So I guess yan yung sinasabi ko. Okay? So you use the generator to support the voltage kasi uh, within a certain system you have it may respond to a certain load, a certain demand, a certain state such that magkakaroon ka ng voltage problems. So you use the generator as voltage support and system frequency. Okay? Kasi when you drop a load or when you drop a generator or when you shed a generator, so it basically affects the frequency of the whole system. Okay? And you want to work you want to operate at a certain system frequency. In the Philippines, you want to operate at 60 hertz plus minus a certain tolerance. So that's basically it. So you use the generator for these functions. So your generator is, well, it's hindi na lang siya ginagamit for producing power to meet the demand. So you have these other functions. Okay? Now, I think for most of this the contents of this discussion will be just skimming the different technologies on generator, on power supply. Yeah, it's not just generators, but most of them are generators kasi yun naman yung large component. It's the majority of your power supplies from generators. So on using conventional methods, we have hydroelectric power generation. In terms of generating electrical energy, well, you use a generator, and the generator from your EE51 before is basically a machine that converts your mechanical power into electrical power. So in terms of conversion of mechanical to electrical, it's basically almost the same for every technology that uses that machine. Okay, so you have a magnetic field, then you have a coil, and then if you move that coil, if you rotate that coil, you induce a voltage, you induce current, so you produce power. So that's basically it. So the main difference is kung saan ba natin kukunin yung ating mechanical power. So one of the earliest uh, technologies on power supply on power supply generation is yung ating hydroelectric power generation. So basically, if we have dams like this one in this example, I got this image from I'm not sure, di ko na mabasa, nasa ilalim siya, kulay blue kasi. I got this from Google, but yeah, I have the link here. I'll put it in the references later on sa pinakadulo. But if you have one of the most common hydroelectric power generation is yung ating dam. Basically, because it generates it's a high capacity. It's a high capacity power plant. It has a lot of potential. It has a lot of power. So basically, what it requires is you have a reservoir, and then you want to harness yung potential energy. That's why kailangan mataas siya. Then, basically, you collect that through a turbine, and then yung turbine iikot yun, and then that rotation will serve as your rotational energy that is to be converted into electrical. So most of the generators actually is using uh, that concept. Nag-iiba-iba lang sila ng prime mover. Okay? For hydroelectric power generation, we have smaller power generations, smaller hydroelectric up to micro scale. Kasi you have developed there are advances in the technology of hydroelectric power like run of river na mas maliit as compared dito. And what's good with run of river is since mas maliit siya, mas madali siyang install. it's well, of course, it has a lower cost kasi majority of the cost of producing this high power hydroelectric is yung construction. It's the construction. Mahal ang construction ito. There's a lot of structural ano to, engineering problems involved in this one. And then yeah, so you have runoff river. It's basically para siyang horizontal. I don't know. Well, you have the vertical, this one pababa kasi yung tubig. So it's dropping into the turbine. It's free falling in the turbine. So if you have a runoff rivers, it's hindi siya babagsak. It's more of harnessing the flow. Okay, harnessing that velocity of water. So yeah. So that's hydroelectric. Of course, you have thermal plants. You are basically thermal generating plants. Most of them are geothermal. You are basically harnessing heat, okay, and then steam to make that turbine rotate. So it converts energy from fuel. You have coal, oil, gas, radiation, and then into electric power through turbine-driven generator. So it's gonna din siya, but it uses steam. Okay, and to produce that steam, have you need to have heat source. So it's thermal thermal plant. Now, I think we have one here in Laguna. And then tama ba? Ito ba yung nasa Laguna? And then synchronous machinery, uh, this is one of the things that I'm saying kanina. So it's not really generating real power. This is its main purpose is to generate reactive power. So why do you want to generate reactive power? If your load customer or your end user is requiring you to have a certain demand in kilowatts. So basically, you want to generate this reactive power to stabilize yung ating system voltages. This is how you support the network. Para hindi ka magkaroon ng failure of the network because of voltage problems. Okay, kasi because your network is very dynamic, okay? Every minute, every hour, nagkakaroon ka ng different loads. You turn on the TV, you turn off the TV, you turn on your light, you turn off your lights. In a higher industrial scale, nag-close natapos ang office hours. So most of the lights are closed, and then nagbukas yung office lights, so most of the lights will turn on. Most of the devices will turn on, most of the devices will turn off. So those types of ramping in loads, they have an effect in the network as a whole, such that they affect the voltages. So you want this synchronous machinery to support the system, okay, by producing reactive power. You'll know more about this when you are in EE15. It's EE151 pa ngayon, but I am not sure it's ano na nga ba yung number niya? 71 yata. 71 yata siya after 62. Okay, so it's power system analysis. So you'll know more about how yung ating reactive power affects yung network, how it affects the voltages, and why is it the reactive power and not the real power. You'll know it's actually quite interesting. Okay, so you'll know more about that later on. Now, for non-conventional methods, dito papasok yung ating renewable, most of them. So you have the wind power. Actually, may renewable din dito. Ito, hydro is renewable, geothermal is renewable. Well, not all of this in the thermal is renewable. You have coal, oil, gas. I'm not sure if no, I think yung radiation. These are not really renewable, but yung gas, if we're talking about biogas, biomass, yeah, it's renewable. Okay, so for non-conventional methods, you have wind power. So it's basically it's also a turbine. It's also a turbine driven generator, but it's harnessing wind. So it dates back as early as 1890. So ganun na katanda yung ating wind power technology. And the Danes were already using 23 meters. So malaki talaga siya, but I think uh, recent technologies have developed smaller wind turbines. Actually, uh, we now have this is horizontal axis and vertical axis wind turbines. Okay. You also have photovoltaics. There's a lot of research on this one kasi most of the research here is focusing on the material used in your solar cells because well you want majority of them is focusing on improving the efficiency of those arrays of those cells. It's first used in power satellites. Well, I think it's obvious why kung bakit. In the middle of 1990s, PV applications were standalone systems located where connection to the utility grid was impractical. So if it's impractical to connect to the utility grid, because uh, if the location is an isolated area, medyo malayo siya sa kabihasnan, then it's actually costly to create a line to reach those areas. Well, of course, eventually you want to reach those areas. You want them to be connected to the grid. Kasi as I have said before, uh, the goal of the IPIRA is 100% electrification. But it doesn't really happen in a it actually takes a lot of time for us to reach that. Actually, we're beyond the target date, I think. Yeah. But yeah. Okay, so PV application makes the availability of electricity in those areas possible. Okay, so practical uses of this is on water pumping systems, highway information signs. Okay, kasi yung highway usually wala naman distribution lines doon eh. Highway usually yung lines mo doon is transmission lines. Okay, just like SLEX, just like NLEX. Wala kang makikita ng distribution lines in them. Usually, yung nagdumadaan doon is transmission line. So it's the use of solar power systems in those areas are very very efficient. I think yeah, efficient ba yung term na maganda? Yeah, practical. It's very very practical. Okay. Hybrid PV powered single family dwelling. So it's good for single family dwelling, but actually even commercial establishments are using solar nowadays like SM North ata yung merong isang malaking solar uh, plant sa kanilang rooftop. I'm not sure of the size, but yeah, it's actually quite big. And then but yeah, this is common in residential areas. Actually, ito rin yung uh, it's because of these technologies na nagkaroon ng birth of net metering here in the country. Okay. It's yeah. Pero meron ba tayong venue later? I think may venue tayo later on to discuss yung ating net metering. Okay. Now, other advanced energy technologies sa iyong ating storage systems, you'll be needing this, especially when you are using uh, solar systems because solar systems available lang siya sa umaga. Okay? So photovoltaics available lang siya sa umaga. So kung walang araw, then wala ka ring power supply from your photovoltaics. That's why you use battery to store that energy from your photovoltaics, and then you can use that energy stored in the batteries later at night. So storage systems, earliest technologies use flywheel storage. It's basically inertia. And then you have compressed energy, air energy, superconducting magnetic energy, and battery storage.